Hi everyone, it's great meeting you all today. So I am Adly MELBA REENA, Assistant Professor, Department of Artificial Intelligence and Data Science. So today the topic which we are going to discuss is search algorithms in data structure. So the searching technique, we start with the arrays. So in arrays we can search an element, either one element from in between or in the ends. So this can be achieved by two different methodologies. One is linear and next one is the binary search. So searching, so what is the search? So an element is being asked to search in an array, that is we are going to find out whether the element, or here we represent it as a key. So we have to find out whether the key is present in the given set of numbers. So that number is called as a key, and for example you can say that in an array of student records we just have to find out whether the detail of a single student whose register number starts with 1, 2, 3, 4 is present or not. Or you can also find out in an array of employees, we just want to find out the details of the person who has the employee ID as 24. So there are two methods we are going to discuss in the search. One is linear search and binary search, and this is depend upon the content of the data that is present in an array. So if the array elements are sorted means arranged in an order from starting from lowest to highest, we go in for the binary search. And if the array is not sorted and it is not sorted and we have a lot of shuffled elements present in an array, we go in for the linear search. So first we will discuss about the linear search. So linear search is, the search starts every time starts from the beginning of the array. So it inspects each and every element in an array. For example, if we are having 5 elements in an array, it starts with the first element. It checks whether the first element is equivalent to the key or not. If it is not matching, then it moves on to the second element and it checks whether the second element is matching or not. And if it is not matching, then it moves on to the third one, and likewise it continues until it reaches, it sees whether the key is being matched with the element. In case if the element is not matching with the key, then -1 will be returned, saying that no such key is present in the array. So in case if there is a key which matches with the element, the position of that particular element will be array. For example, if the first element matches with the key, then the position will be 1. The answer we get is 1. Or if the fourth element matches with the key, then the fourth position will be given as the result. So here, based on the time taken to meet the result, that is whether the first element or the fourth element or the fifth element, the time taken to find out the key is said as the time complexity. So time complexity is nothing but how long the algorithm runs to find out the result. So if there are n elements in an array, the best case is like it will be if it is the first element. If the first element matches with the key, then it is the best case, and the search value, the time complexity will be 1. And worst case is there is no match. All the elements, if there are n elements in an array, none of the element is matching with the key, then it is the worst case and it will be of n search operations. And average searches, average searches within the middle of the array, you are able to achieve the record, you are able to find the record, and so the average case will be n plus 1 by 2. So this is the basic idea about linear search, and this is the algorithm. So algorithm in sense, so what and all will be there is the array, the needed thing is the array, what is the size of the array? Size of the array is how many elements are present in an array, and what is the key which we are going to search. and we have a temporary variable which has the position. So this POS will return the result of the search. So we are seeing whether the POS is lesser than size and the array of POS is not equal to key, we are shifting it to the next one. So if the POS exceeds the size, we just have to return it as -1. And if it is not exceeding the size but you are returning the value, then you have to give the position. So this is the case with this. So we'll see it in this example. So what happens in this is, there are actually 1, 2, 3, 4, 5, 6, 7, 8. 8 elements are present in this array of X, and that is given as the second value, and 6 is the key which we have to search. So first it comes to the first element, so POS will be 1, and it will check whether POS of 1 is equal to 6 or not. So it is not equal to 6, so the position will be increased, POS will be incremented, and then POS of 1 will be checked with the key and it is not matching, so POS will be incremented, and POS of 3 will be checked with 6 and it is not matching, so POS will be incremented and it moves on to 4 and it checks, and finally when POS is equal to 5, POS of 5, A of POS and the key is equivalent, so the result that will return is POS is equal to 6. So the index of the element which is matched with the key is 6. So that will be the result here. Result is 4. Sorry. And in the next case, we are going to search whether 5 is present or not. If whether 5 is present, there is no such records in the array. So it just traverses all the elements, that is 8 elements in the array, and find out that there is no record, and finally it returns -1. So this is with the linear search. Now we will go with the binary search. So for the binary search, we have to be very sure the array is sorted or not. It is arranged in an increasing order. So the binary search works well if the array is sorted. So it targets the middle of the array. In case if there are 5 elements, it starts with 3. If in case there are even numbers like 6, then it takes like n plus 1 divided by 2. So it looks the target in the middle. If the middle element is not matching the key, then it finds whether the key is lesser than the middle element or greater than the middle element. If the key is lesser than the key element, then it starts traversing in the left side. If the key value is greater than the middle element, then it starts traversing from the right side. So this is the overall method that has been followed here. So here the worst case will always be half, but in the linear search, the worst case is always n. So this is the difference between the linear search and the binary search. So what it will happen is, you will have 2 keys. So the first part will be the value that is lesser than equal to key, and the next part, the second half, is the values that is greater than key. So you are splitting the given array into 2 halves. So it searches whether the middle element is equivalent to key or not. That is the first search, and if it doesn't satisfy, it checks whether it is lesser than key or it is greater than key, and then it moves on to this particular part as an array to be taken, and it does this operation. So initially it starts with L and R. L is the initial value and R is the final value, and final value means the last element. So and then the situation occurs. So the index it will be taking in this manner, L plus R divided by 2. So this will be the movement of L and R is based upon the value that we are searching. So you can see here the key will always be in the size of 0 to size -1 and it returns. If it is present within that, then it returns its location, or else if the key is not present in that particular array, it will be returning as -1. So this is the syntax of it. So the needed one is array, the size of the array, and then the key which we have to search. So these are the intermediate values that is very much required to do the calculations. So this is the algorithm for binary search. What we do is we are just checking the middle value. We have each and every time the middle value will be changed. If for the first time the middle value will be L plus R by 2, and if the middle value is lesser than and equal to key, then L is equal to mid, else R is equal to mid. So it keeps on changing based on the middle value. So you can see here the condition that we are going to check is L plus 1 is not equal to R. That is the final condition that we are going to check. So until we reach this particular part, when L plus 1 is equal to R, we stop the operation. So until this, the mid value is calculated based on the L and R, and L and R value have been adjusted. So if L is greater than equal to 0 and x of L is equal to key, then the position of that particular key will be returned, or else you are giving the result as -1. This will be done after the running of the loop. So this initial condition, see, when we take the values as L and R, there is an initialization of values for the L and R, which is very important. So the initial value of L will be always -1, and the initial value of R will be the size, because L is the initial element, and that is the first element, and R is the last element in the array. So the binary search example, we'll just see what happens in this array with an example. Second case, when binary search of x9 145 is also not present here. We have 21 and 45. It is totally different one. Here in this case also we'll get the value as -1. The last one, the binary search of x9 45 is there. So we will find out how it happens here. So it divides into two equal parts. -17, -53, 6, 12 will be the first part, and 21, 45, 63 and 50 will be the second part. So what is the key value here? 45. 45 is greater than this value. What is the intermediate value? Which is 12. So the intermediate value is 12 and 45 is greater than the intermediate value. So it takes this particular array, which is the second group. So it comes to the second group, and L will be equal to 21 and R will be equal to 50 now. And in this part 21 and 50, it again starts finding the middle value. What will be the middle value now? The middle value will be 45. So 45, and it checks whether 45 is equal to the key. Key is again 45. So it will take the position of the 45, and that will be printed as the result. So that will give us the position of it. So the result will be 6. So by doing so, we can get the result in a very quicker manner, and this can be achieved only with the sorting of the arrays. So what is the trouble in it? So suppose we have 1000 elements in an array. 500 comparisons, it's not like, it is not feasible to it. So we have to have it as a for linear search. If we go for a linear search for 1000 records, we at least 500 records we have to do it. And for binary search also, we can if we have 1000, within 500 itself we can refine the search and find it out. That is the first thing for it. But when we go for the linear search, it's a very bigger task and time consuming, and the time complexity is also high. If there are n elements in an array, the number of searches that is required to find the element will be log n base 2, and if n is equal to 64, then the list size will be 64, and the log will be the time complexity taken to find the n elements will be n. Okay, so this is the thing. So first comparison, the list will be 32. After the second comparison, the list size will be drastically reduced to 16. The third comparison, the size will be again decreased to 8. So at last, in this particular one, if we say sixth one, the comparison will be 6. So this is based on the time complexity. Now we will discuss about the previous questions that has been asked in GATE. One of the question which was asked in the GATE was, which was the given statement is the correct recurrence for the worst case scenario of a binary search. So there are 4 different answers here. Time complexity of n is equal to 2 into t by of n by 2 plus big O of 1, and time taken to take one record is equal to big O of 1 is equal to time complexity of time taken for 0 record. And next one is time taken for n minus 1 record plus big O of 1, and time taken for 1 record is equal to big O of 1 is equal to time taken for 0 records. The next one, t of time taken of n by 2 plus big O of 1 plus, and time taken for 1 record is equal to t of 0 equal to O of 1. And the last one is t of n minus 2 plus O of 1, and t of 1 equal to t of 0 is equal to O of 1. So there are 4 different strategies, 4 different answers that it's given. We have to find out which is the correct statement for the worst case scenario of the binary search. So how is the binary search happening? Binary search, if the first record in the binary search is the key, then the time complexity taken for that particular record is t of 1, or big O is 0. So there is no need for that. Sorry, time taken for that is 1 and the big O of 1. And if the first record is not the key, so what we have to do, it will be traversed in the manner of n time of n by 2. Then n will be divided by 2 plus 1. So this will be the formula for finding out the next set, and that will again be divided into n by 2. So the correct answer for finding out the worst case scenario in the time complexity is the option C, which is Tn is equal to Tn by 2 plus O of 1, and T1 is equal to T0 is equal to big O of 1. So this is the third one is the answer for this particular question. Next question, it's slightly similar to this. So a sorted array is given to you, and what can be the minimum worst case time complexity to find out the ceiling of a number x in a given array? The ceiling of an element x is the smallest element present in the array greater than or equal to x. The ceiling is not present if x is greater than the maximum element present in the array. For example, if the given array is 12, 67, 90, 100, 300, 399 and x is equal to 95, then the output should be 100. So what will be the time complexity? So the same formula has to be used. So we know the time complexity is log n base 2. So this is the time complexity, and here we have the worst case scenario, minimum worst case scenario they have asked. So the answer is the C1, which is O of log n. The same thing which we said before, the time taken for computing the records, to find the records in an array is n by 2 plus 1, time taken by 1, and it will be successfully done, and finally it comes to the method of O of log n. So with this basic we can solve such questions for which comes with the search of the array. So I hope you have learned about the searching techniques, binary search and the linear search. So it's great connecting you all. We'll meet in the next session. Thank you.